Dear students, in today's class we will discuss Coulomb's law in vector form. In the previous video we have discussed the Coulomb law. Today we will discuss it in the vector form. You know that what a vector is? If I say A is any vector, then it means that A will have a magnitude as well as direction. Then we will discuss problems based upon the Coulomb's law. We will discuss problems. Then we will discuss the units of the charge as Coulomb. We will derive, or you can say we will define units of charge as Coulomb with the help of Coulomb's law. Then we will discuss dielectric constant. Dielectric constant is important. It can be asked as a short question in your board exams. Now, to discuss the Coulomb's law in vector form, let us recall the things that we define the Coulomb law as F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R square, where Q1 and Q2 are two charges separated by a distance R. So, in vector form, what we did, we placed the charge Q1 at point A and charge Q2 at point B, such that we have origin O such that OA represents this OA. I am putting lines on it. This OA represents vector of the charge Q1, which is equal to R1. Similarly, OB is vector for the charge Q2, which is equal to R2 vector. Then we know that by using the triangular law of vector addition, we can calculate the things. Let me explain the triangular law of vector addition. If there are three vectors A, B, C, then A vector plus BC vector will be equal to AC vector, right? Because AB vector and BC vector are in same direction, but the OC vector is in opposite direction. So AB vector plus BC vector is equal to OC vector. This is triangular law of vector addition. If the situation has been so that you have the vectors A, B, C and all the vector follow the same direction, then AB vector plus BC vector plus AC vector will be equal to 0, right? So if you look at this triangle, OA, OB are two vectors and R12. R12 is the distance between the charge Q1 and Q2. If it is R12, it means that if it is R12 vector, it means that the distance or you can say displacement, as it is having direction to the distance between Q1 and Q2 such that motion starts initially from Q1 and ends at Q2. Similarly, if you write R21, it means that the distance is traveled from Q2 to Q1, right? So this 1, 2 and 2, 1 is changed depending upon the initially from which charge you are starting. So here we have written R12. If you apply triangle law of vector addition over there, you can easily look that OA plus AB, they are traveled in same direction, starting from this point to this point, but your OB is in separate direction, so it is equal to OB vector, right? So by using this equation, I am going to circle this particular equation. By using this equation, we can write this thing, that your AB vector, this AB vector, we can write AB vector is equal to OB minus OA, right? So AB vector is equal to OB minus OA. It means that, what is your AB vector? AB vector is R12 vector is equal to OB vector, which is R2 vector, minus OA vector, which is R1 vector, right? So by using this, you can write this equation which says that R12 is equal to R2 vector minus R1 vector. We get this equation by using triangular law of vector addition, which we discussed, right? So as you have written AB vector, similarly you can write BA vector. This BA vector is R21 as you are moving from charge Q2 towards the charge Q1. So it will be equal to R1 minus R2. The magnitude of R12 vector is R12 and R21 is R21. They both have same magnitude, but they have different direction. Then by applying the things to the Coulomb law of vector addition, both have same magnitude only, but the direction is different. Then we use the Coulomb's law, that is F12 vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R12 square, right? We have added the unit vector which has a value of vector divided by the magnitude, right? Because we have defined the vector as vector is equal to the magnitude and the unit vector. So unit vector will be vector divided by its magnitude. So we get this thing, that it is equal to R12 cap, this thing is called cap, is equal to vector divided by its magnitude. If we make the substitutions for the unit vector, then F21 can be written as 1 upon 4 pi epsilon naught Q1 Q2 are the charges divided by R12 cube. It will get cube as you put here R12 vector. What we have did, we have just substituted this value in the expression. Then we can write 1 upon 4 pi epsilon naught Q1 Q2 R12 cube. R12 can be written as R2 vector minus R1 vector. We have derived this thing by using the triangular law of vector addition. Even this equation can be more simplified if you write 1 upon 4 pi epsilon naught Q1 Q2, the charges, the magnitude can be written as R2 vector minus R1 vector cube into R2 vector minus R1 vector, right? So this thing is called the Coulomb law in vector form. This particular expression of F is the Coulomb law in vector form. I am going to highlight it. So this expression is the Coulomb law in vector form, right? Now, as we have talked about the direction in this article, so as we have added the direction to Coulomb's law, the polarity of charges play important role. We know that unlike charges attract each other and the like charges repel each other. Now, if you have two charges Q1 and Q2, if both these charges are positive, if both these charges are positive, we know that unlike charges attract each other and the like charges repel each other. We take two charges Q1 and Q2. We write product of the charges as Q1 into Q2. If the both charges are positive, it means that the Q1 and Q2, the product will be greater than 0. If both the charges are negative, then again you know that negative multiplied with negative will give you a positive number. So again the product will be greater than 0. But if you have unlike charges, one charge is positive, another charge is negative, or first one is negative and another one is positive, due to that their product will be a negative number and Q1 into Q2 will be less than 0. Right? So if you look at this figure, here you have put two charges. The first charge is Q1, second charge is Q2, and you have taken the product of both charges to be greater than 0. It means that both the charges are like charges. Either it is combination of positive charge or it is combination of negative charge. So like charges will repel each other. So that's why the force is F12, that is the force on the charge particle 1 by 2, and F21, that is the force on the charge particle 2 by 1. Both are outward as the force is of the repulsion. So both are made outward from the central axis. The second case is when the charges are unlike charges. It means that Q1 and Q2 is less than 0 by this equation. So it means that they are unlike charges, and unlike charges are going to attract each other. Unlike charges are going to attract each other, due to which the force will be directed inward. So the force is directed inward and the force is attraction. That's all about the Coulomb's law in vector form, and from this conclusion we can say that the force on the first particle by the second is equal to negative of the force on second particle by the one. We can make this conclusion that F12 is equal to negative of F21. That is the Coulomb's law in the vector form. Let us discuss the first problem. In first problem says that there are two charge particles having charge. This is the value of charge. Both have same charge. So we know that Q1 is equal to Q2 is equal to 2 into 10 raised to power minus 18 Coulomb. That is the value of charge, right? Are joined by an insulating string, means that you have two charges. The first charge is Q1 and another charge is Q2. They are joined by an insulating string of length 1 meter. What does it mean? It means that the distance between the charges is 1 meter, right? They are kept on a smooth horizontal table. Find the tension in this string, right? So you know that the tension in the string will be exactly due to the repulsion force between the charges, as both are the same kind of charges. They both seems to be positive charges, so they are going to repel each other, and but they are held stationary due to a insulating string. So they are held stationary due to an insulating string. So the string will have to work. The string will have tension that is equivalent to the Coulomb repulsion, right? So the tension in string will be same as that of Coulomb force of repulsion, that is 1 upon 4 pi epsilon naught Q1 Q2 by r square, right? And the value of 1.4 epsilon naught, we know it is 9 into 10 raised power 9, right? We did it in the previous video. And the values of charge, we substitute 2 into 10 raised power minus 18 square, as the two charges are there, so we write minus 18 square multiplied divided by 1 meter square. So everything is in SI units, so we write it as such. If you calculate it, you will get the answer. So it comes out to be 36 into 10 raised power minus 27 Newton, right? So let us discuss the next problem. In the next problem, we have a particle that is placed at the center of the sphere. We have a charged particle that is plus q that is placed at the center of the sphere, right? We have the sphere each of length 1 meter. Length of sphere side is 1 meter. That is again provided in the question, right? So if it is so, now we need to calculate what is the net force on the charge q. What is the net force on the particle at q? What we have at the O? At O, we have charge q, and the value of this charge q is 2 microcoulomb. This value for charge q is given, that is equal to 2 microcoulomb. Let me repeat the things again for you. What is in the figure? In figure, we have a plus q charge at origin. At this corner, we have minus 6q charge. At another corner opposite exactly to it, we have minus 6. We have minus 8q charge here. Opposite side again minus 8q. We have plus 7q charge here and minus 7q charge here. We have plus 4q charge here and we have plus 4q charge here, right? So we will discuss the charges one by one. This q will be exerted by a force by this minus 8q charge. But this is gonna balance with this minus 8q because the amount of force will be equal, right? Then this minus 6q force is balanced by this minus 6q. Then this plus 4q will be balanced by this plus 4q, right? So all these forces will be balanced up. The force will come from plus 7q and minus 7q, right? So if you write the net force on charge q at point O, right? So it will be 1 by 4 pi epsilon naught. First of all, let us write for plus 7q charge. For plus 7q, we will have, we know Coulomb force is F upon 4 pi epsilon naught modulus of q1 divided by q1 q2 modulus. So modulus is there, so it doesn't matter whether the charge is from plus 7q or the charge is minus 7q, the amount of charge will remain same. So it is 7q divided by the distance, right? So net length of this sphere is 1 meter. This is at center, so half of 1 meter is 1 by 2 meter, so which can be written as 0.5. So it is 0.5 square, right? So it is M material whether the charge is from plus 7q or minus 7q. So we can directly multiply this particular thing by 2. So on simplification, when you further simplify the equation, you will get it equal to, come on, pick up your calculator, solve it. This is 2.016 Newton, right? Newton are the units of force. Now let us discuss the problem third. In third problem, what we have two fixed charges. Those are plus 4e and plus e. They are separated by a distance a, right? So we are going to draw it. So what we have two charges. One is plus 4e, another one is plus e, right? Both these charges are separated by a distance a. So distance of separation between these two charges is a, right? Where should the third point charge be placed such that the charges, that particular charge is in equilibrium, right? So we need to mount the third charge. Say, for example, we take the third charge to be positive q, right? Say we put positive q here, right? And the distance between the positive q and the charge 4e be x. If this distance is x, then the total distance is a. It means that this particular distance left will be a minus x, right? Say F1 is the force. F1 is the force on charge plus q by plus 4e charge, right? So it will be F1 will be 1 upon 4 pi epsilon naught q into 4e divided by x square, right? Then F2 is the force on charge plus q by e, right? Then F2 will be equal to what? 1 upon 4 pi epsilon naught, product of charges q1 q2. One charge is q, another is e, divided by the distance. Distance is a minus x. So we take a minus x ka whole square. So we write this equation as equation 1, this as equation 2, right? Then we equate both the equations. F1 should be equal to F2. This is the condition for the equilibrium. F1 should be equal to F2. So what we have, q into 4e divided by 4 pi epsilon naught x square should be equal to 1 upon 4 pi epsilon naught a minus x whole square. On the upper side we have q into e. Q will get with cancel out with q, e will get with cancel out with e. 4 pi epsilon naught terms are going to cancel out, so we will be left with 4 by x square should be equal to 1 minus a divided by x square, right? So we have 2 by x is equal to 1 by x. We take square root on both sides. On simplifying the things, we have x is equal to 2a by 3, right? So x is equal to 2a by 3. So this is the distance. This is the distance of charge plus q from plus 4e at which forces will get balanced. Right? The next is the second last topic of the video, that is about the units of the charge. We all know that the units of the charge are Coulomb, right? we are already familiar with this thing. This unit of charge, Coulomb, is to be defined from the Coulomb's law now, right? So for that, we write the Coulomb's law. We assume that the force is 9 into 10 raised power 9 Coulomb when you have two same kind of charges. When Q1 is equal to Q2 is equal to Q. The charges are same and they are placed at a distance of 1 meter. Then by making the substitutions in the Coulomb's equation, that is equation A, we have 9 into 10 raised power 9 is the amount of the charge. This is the value of 1 upon 4 pi epsilon naught. Charges we have written QQ, the same. Then Q comes out to be plus minus 1 Coulomb, right? This is the SI unit of the charge, right? So 1 Coulomb can be defined as the value of the charge when they are placed in vacuum at a distance of 1 meter from each other and they are repelling each other with the force of 9 into 10 raised to power 9 Newton, right? So 1 Coulomb is that much charge which will repel each other with the force of 9 into 10 raised to power 9 Newton. The condition is that they are placed in vacuum and the distance between them is 1 meter. The next are the CGS units of charge. The CGS units of charge are two types. One is ESU, another is the stat coulomb, and 3 into 10 raised to power 9 stat coulomb is equal to 1 coulomb. This conversion is important for numerical point of view. This thing you should learn that 1 coulomb is equal to 3 into 10 raised to power 9 stat coulomb, and 1 stat coulomb will be 1 divided by 3 into 10 raised to power 9 coulomb. The next is about the dielectric constant. Dielectric constant is again an important question, right? Dielectric constant is also called relative electrical permittivity, right? So we write two equations. The first, the Coulomb law, when the charges are in medium, the Fm represents the force between the charges Q1 and Q2 when they are placed in medium. Epsilon is the absolute electrical permittivity when the charges are placed in medium. Then F0 when the charges are in vacuum. Then we divide both equations. We get F0 by F1 is equal to this, which comes out to be epsilon divided by epsilon naught. This ratio is called dielectric constant, that is K, and ER. ER represents the relative electrical permittivity. ER is called relative electrical permittivity. K is called dielectric constant, right? So dielectric constant or the relative electric permittivity is the ratio of the amount of the force when the charges are placed in vacuum divided by when both those charges are placed in some medium, right? Then F0 when the charges are in vacuum. Then we divide both equations. We get F0 by F1 is equal to this, which comes out to be epsilon divided by epsilon naught. This ratio is called dielectric constant, that is K, and ER. ER represents the relative electrical permittivity. ER is called relative electrical permittivity. K is called dielectric constant, right? So dielectric constant or the relative electric permittivity is the ratio of the amount of the force when the charges are placed in vacuum divided by when both those charges are placed in some medium, right? While defining the Coulomb's law in the video, we said that The Coulomb force is dependent upon the medium, right? Because epsilon m and dielectric constant are the properties of the medium, right? So dielectric constant is the ratio of the force of interaction between the two point charges in vacuum divided by to that when the charges are placed in vacuum. That's all for today video. If you find the content useful, kindly like, share and subscribe my channel.